Hello students, in this video we'll see how to solve problem 6.4.101. Problem 6.4.101 asks us to analyze the systems without solving. The system that's given to us in part A is the system x prime of t equals x of t plus y of t, and y prime of t equals x of t minus y of t. In this system, in matrix notation, we can write this as x prime of t is the matrix 1, 1, 1, negative 1, x of t. And we can find the eigenvalues of this matrix. The eigenvalues are found by computing the determinant of 1 minus lambda 1, 1, negative 1 minus lambda equals 0, which gives us 1 minus lambda, and then negative 1 minus lambda minus 1 equals 0. And we can write this as lambda minus 1 times lambda plus 1 minus 1 equals 0. So foiling this out, we will have a lambda squared. We'll have a negative lambda and a positive lambda. Those will cancel out, and I'll have a negative 1 and a negative 1. That's a negative 2 equals 0, which tells me that lambda equals plus or minus the square root of 2. So I have equal and opposite. I have one positive and one negative eigenvalue. That tells me that the origin is a saddle point. So we have a saddle system. In part B of this problem, we're asked to analyze the system x prime of t equals x of t plus y of t. Y prime of t is 2y of t. The matrix formulation of this system is x prime of t is the matrix 1, 1, 0, 2, x of t. And we see that we have an upper triangular matrix. And so the eigenvalues of this matrix are going to be the diagonal entries, are 1 and 2, which are both positive, which means the origin is an unstable source. Part C of the problem asks us to analyze the system x prime of t is negative 2y of t, and y prime of t is 2x of t, which as a system looks like x prime of t is 0, negative 2, 2, 0, x of t. We can see the eigenvalue equation for this will be determinant of negative lambda, negative 2, 2, negative lambda equals 0, which will give me a lambda squared plus 4 equals 0, or lambda equals plus or minus 2i. And I have two purely imaginary complex conjugate eigenvalues, which tells me that the origin is a center or orbit of the system. So we have elliptical trajectories centering on the origin over here. Thank you very much.